Good afternoon, seventh graders. Um, I'm waiting for some participants to join. So this is gonna be our first class. Let me see, I have somebody right now. I'm writing here on the chat. We are supposed to use the chat as our way of interacting. So use this chat to make questions or any comments related to the class. To today's class. And when you get in here, say hi. When you come in, please say hi. So who do I have here? Let me see if I can see who I have. No, I cannot see until you say hi. Okay, class. So welcome to the fourth partial. I hope your families are well, and so are yourselves, your body and your mind. And so this is how we're gonna do it now on. I hope that we can do it better with time. We're gonna learn better techniques. As you can see, we are getting better than how we were at the end of the third partial. Now we have created a website. We have video classes like this one and others that experimentation point with a crisis that has never happened. But it's good to know that we, as humans, as intelligent beings, I'm having problems with connection, so it seems. Hello, welcome back. So I'm having some internet problems. I hope that I don't have any more of these problems. I'm also connecting here. Computer, thank you. So, as I was saying, we've been adapting. We always evolve. Remember this from our science classes. And that is basically today's main topic, is how we have evolved. Let me look for something. Wait. I'll look for something that will raise my whiteboard. So that I can use more space without sacrificing my head. Oh, we'll just leave it there. I'll sacrifice my forehead. So we are in a point in our class that it's very interesting, the things we're learning. Remember that it's all about what we learned. Life. And we're learning many things right now. As a species, humans, we are now learning how to live in our houses more time than we used to. So we are adapting. This is just one of our formidable ways we have evolved. And I want to make this as a reminder that we are animals and we are beings of this ecosystem. This is our ecosystem, and this is how we interact with all the living and non-living things. Now, how did we get here? Actually, this is proven. We have found evidence of how we as humans have come to what we have come. And it's been a chain. So I'm going to connect right now what we learned from all that we have learned before especially from the third partial, about animals and how we got here as human beings. So, one of your homeworks of the third partial was the evolutionary tree. Remember. So, evolution, the science behind evolution has taught us evidence of how we have changed throughout geological time. Geological times means a lot of time, millions of years, okay? Hundreds of millions of years, even billions of years. Actually, we can say that approximately, we don't know how long ago, but approximately some 3 billion years ago, that is 3 with 9 zeros after it. So this is 3 billion, imagine. Human beings, we usually age up to, let's say, 70 years is the life expectancy. So it's a lot of times what we usually have done. 3 billion years is extremely a lot of time. So 3 billion years ago, we don't know how. That is something science cannot prove, but it's still looking for the answer. We don't know how, but the initial life forms began. And some of these life forms began, we all know that life, as we have defined it, is defined by having a cell. It's defined by the cell theory. So the first and most simple type of life, which began billions of years ago, were simple types of life. Unicellular, one-celled organisms. They were very small, but there were also some that were larger. And in this primordial waters that life began, created one of the first unions of two different species, the first interactions between two different types of organisms. One of these, of the smallest of the types of organisms, decided to go live inside the biggest type. So what we have here now is a mutualist relationship, remember, a win-win relationship in which we now have a new type of organism. And this type of organism that went inside was very special because he had learned to use the power of the sun to make its own energy through the process we know as photosynthesis. When this little guy came inside the other bigger cell, it gave its power of photosynthesis to the bigger cell. Now, this cell also has the power of photosynthesis. But there is also another very important type of unicellular organism that existed. And this one had the power to use oxygen which is the gas that we breathe in the air. It had the power to use oxygen and also eat from other products to make what we call cellular respiration. Because initially, the other types of unicellular cells did not know how to make cellular respiration. And how do we know this? Because so this type of unicellular organism learned to make unicellular respiration. And he also decided to go live inside the bigger unicellular organism. Why? Because maybe they had protection. It had to have something that benefited. So now we have an organism that can do both things, can make cellular respiration and can also make photosynthesis. So we now have a type of organism that can live in two ways. They can live as producers making photosynthesis, but they can also live as consumers using oxygen and food for their energy. We have a very special type of organism that we call cyanobacteria. Okay, we have talked about cyanobacteria before. If you don't remember, go back to the second partial. Or was it the third? I don't remember. So I'm gonna make this quick because this takes a lot of time in geological years. Remember, from 3.3 billion years ago to passing through hundreds of millions, tens of millions, we're gonna see some evolution happening. So through time, by mutations and by adaptations, one group of these cyanobacteria decided to continue having both organelles. Okay, continued having both organelles. The organelle for photosynthesis and the organelles for cellular respiration. And they evolved to become algae and plants. But the other group, there was another group that, by ways of natural selection, became another thing. Now, this group left off, they did not conserve the organelle for making photosynthesis. They only conserved the organelle for cellular respiration. This group would lead to all of the other types of consumers, which also got divided in the process. In one group, in one branch of the tree, we have protozoans. And from another branch, we have fungi. Remember fungi? That doesn't look like a fungi. Like a fungus. This looks more like fungi. Okay. Now, evolution continued happening. And next to protozoans, very close to protozoans, we have a group of protozoans, which we remember that protozoans are still unicellular organisms, but they are very diverse types and very mobile, that have locomotion type of unicellular organisms. They are large also, very much larger than our original cyanobacteria. And as Remember that when we saw sponges, that sponges were just like so simple that they could be considered unicellular colonies? Because sponges are very close to protozoans. Sponges, as we remember, are just have just one type of cell, and they appear very much like a colony of protozoan. So in this group we have sponges. Now, very far, very different group was another type of group that evolved was coelenterate and worms. So if we remember worms, worms are also in the group that evolved distinctly from a different branch than from the protozoans. We also have coelenterates in the way, different. And if we remember the worms, we have different types of worms. We have flatworms that were the most simple type of organisms, but then also we had the were not organisms, the most simple types of worms. But then we had roundworms that were also were more that had more structures and were a little bit more complex than in flatworms. And eventually we had another jump of evolution into segmented worms. Remember segmented worms like earthworms? So we begin with worms that are basically flat to worms that are round to worms that are segmented, and in each of the segments they have more structure. Every time they have a little bit more structure. Now, we're going to continue with this branch because I didn't get enough space. So I'm going to erase this and continue where we left off over here in this branch. You also have this branch in your homework about the evolutionary tree. Now, so let's go back. Let me use a little bit more the whiteboard. So if we're gonna begin over here, where protozoans and then we had sponges, but in another branch we had coelenterates. We have the worms, flatworms, roundworms, segmented worms. And let me tell you that one of the branches of segmented that developed separately from segmented worms led to arthropods. Remember arthropods? Arthropods, yeah, we have the insects, the arachnids, crustaceans, and myriapods. Remember those? So yeah, they developed into their own different branches. We have insects. We have the arachnids. We have the crustaceans. and we have the myriapods, all with the different characteristics. So they are the arthropods. We can say that they are the most advanced or the most evolved, the most modern of this side of the branch. But there's another side of the branch from the segmented worms, and I'm gonna use it in black now because this is our branch. Now, another branch different from segmented worms and the arthropods was the branch of the echinoderms. So am I telling you that in some way we are more closely related to echinoderms than to arthropods? Yes, this is what I'm telling you. And when I talk about relationship, I'm talking about like ancestry, which one is more primitive than the other. Okay? It means that one of our ancestors was similar to them. That's what I mean. Okay? There was one of the ancestors, and we remember that echinoderms are starfish, urchins, sea lilies, sea dollars, all these different sea cucumbers, these different types of organisms that are very strange, that are very, and not strange, but different than us. They have radial symmetry, for example. But in one of their parts of their life cycle, they have bilateral symmetry, the trait that we know that we are, right? It's when in the larva stage. Okay? In the larva stage, they have bilateral symmetry. So remember what a larva is? So a larva is like a little worm. And one of these larval stages decided to stay larva forever, conserving bilateral symmetry. This is our line of ancestry. This larval stage passed through different stages. First of all, it developed a primitive vertebral cord, a spinal cord, I mean. Okay? It developed the first spinal cord. So this is the rise of the vertebrates. Okay? And this first spinal cord is what gave them their name, chordates. Okay? Chordates for the word spinal cord. The chordates, evolved in ocean water as everything before. There is still no animals on land. Not even plants on land yet. All of this is happening on the waters. By the way, water's here. So the first chordates look like this. Check them out. One of the common insignia chordates is this little guy. He's called Amphioxus. Okay? You can look him up. Amphioxus. Amphioxus. He looks like a tiny little fish. Like a wormy little fish. Now, from chordates like Amphioxus evolved the first vertebrates. Fish. Fishes in plural because they are different groups. Okay? We have 3 groups of fishes, and we will see the evolution of each of the types of fish. One of the groups of fish are called, and we have them in the book. Please have your book ready. I'm gonna go get my book so that we can be on the same page here. Hello, I'm back. So, by the way, um, the the evolutionary tree that I'm talking about is this one. Let me thank you. Is this one? Remember that I gave it to you? You had a photocopy, so you can look it up. This one's more detailed. Mine's a little bit twisted, but they are basically the same. Okay. Now, in our class, life science book, we begin the fourth partial, with vertebrates, which is us. And the first vertebrates that evolved were fishes, amphibians, and reptiles. Let me give you some data on them because I had some, 8th grade has some good material on them. Yeah, from 507, like they started to evolve like 300 million years ago. Okay, fishes. Let's say that about 300 million years ago, fishes started to evolve. And how do we know this? Because of fossils. Fossils, people. We know this happened. This is not invented. Okay, this is evidence. So, going back with fishes, we have 3 types of fishes. So, if you can open your book to page 372. Page 372. And we will begin to see the evolution of vertebrates, which will end with us, with our evolution. So, fishes, there are 3 different groups of fishes, and we can see the evolution of their different traits, their different characteristics. The most simple type of fish, well, by the way, fish, unlike us, they are called cold-blooded. This is our first vocabulary word, first glossary word. Cold-blooded means that it's not that their blood is cold, it's that they cannot produce their own body heat. The only 2 types of organisms that can produce body heat are mammals and birds, but we will see them later on the next class. So, fishes, amphibians, and reptiles, they are cold-blooded because they cannot produce their own body heat. Okay, and that is one of the evolutionary characteristics that I'm talking about. Because these animals, we can say that they are adapted to different things by being cold-blooded than warm-blooded organisms. We're going to talk about it when we go to warm-blooded organisms. But one of the characteristics I want to talk about the different groups is the existence of a jaw. This is our jaw, mandibula, mandible, the jaw. So, Amphioxus did not have a jaw. No. They didn't have a jaw. The first type of fish, and why do we call them fish now? Well, they have certain characteristics that make them in common. For example, all fishes have, if we can go to on page 373, we can see that all types of fishes have gills so that they can breathe. So let me make a fish over here. Any type of fish will have the following. They will have eyes, which is a characteristic that Amphioxus had. Amphioxus did have eyes. Now, all fish have gills. These gills that is how they breathe. Water enters through their mouth. In some way, whether they have a jaw or not. For example, jawless fishes don't have jaws. Jawless means that they don't have. Jawless. So But they have the other characteristics of fish. Water gets through their mouth and then comes out through their gills. And inside their gills, they can absorb oxygen. This is what they need. Because in the water, oxygen is dissolved. That is why in aquariums, you have to put a pump pumping air inside the aquarium so that oxygen is dissolved in the water. Because if you have an aquarium and if your fish does not get pumped oxygen, the fish is going to die. Okay? They need oxygen. In the oceans, oxygen gets in through the waves. Okay? So oxygen is getting in all the time because of the wind and the waves. So in the ocean and on a river and on the sea, on a lake, you usually have oxygen, which is, remember, the characteristic of the initial type of organism that we remember, because they need oxygen for what? For cellular respiration. All of the consumers, all of the animals, we need to have cellular respiration. Okay. Now, what is another characteristic of fish? They live in the water, be it salt water or be it fresh water. That doesn't, that depends on each of the fish. Each species of fish is adapted to being on salt water or on fresh water or on brackish water, if you remember, which is a mixture of water, of salt and fresh. Now, fish also have fins. Yeah, fins, like Adventure Time fin. They usually have fins. So this is, and inside their body, they have other structures that we will analyze a little bit later. For example, they have a heart. They have all of the same organs. What organs? Let's go to page. If you can go to page 375, you will see the different organs that a fish has inside their body. They have, just like us, just like mammals, they have a brain, they have heart, they have the liver, they have the esophagus, they have the pylori, which is the intestine, they have the stomach, they have sexual organs like the ovary, they have the intestine, they have the anus. So we have a lot of characteristics as fish. I want to talk about one characteristic of fish, their heart. Let me talk about their heart. The heart of a fish has two cavities. Okay? We will see about the heart a little bit later. But talking about the heart of all fishes has two cavities. A spoiler, how many cavities does the heart of a mammal have? 4. Okay? 4. Fish only have 2. Is that an evolutionary characteristic? What do you think? Okay, so this is the characteristic of fish. Now, let's see the difference between the types of fishes, the 3 groups. So we have the jawless fish, like this little friend here that we have, the lamprey and the hagfish, Lamprea y pez bruja. So you can see that they do not have a jaw. Their mouth is like a circle. Okay. In the past, when they were evolving, they were the only types of organisms of fish they existed. So all the fish, the first type of fish, all of them were jawless fishes. Okay? All of them. But, and something about their body, the skeleton of jawless fish is not of bone. It's not of bone like us, that we are bony. No, the skeleton of jawless fish is of cartilage, like this. This is cartilage. We also have cartilage here. So, as we can see, cartilage is softer than bone. But that is the beginning of a skeletal system. So, jawless fish, like the lamprey and the hagfish, they're all fishes, but they have no jaw. Okay, so they have all the other characteristics, but they don't have a jaw. And their skeleton is made of cartilage. Okay, so they have a cartilage skeleton. Let me make cartilage here with blue. Okay, so this is cartilage. Or no, better with black, but in a dotted way. Here. So here we have cartilage. They have a skeleton made of cartilage. Okay. Now, eventually, some jawless fish, another group evolved to have a jaw. Okay, and this one we called cartilaginous fishes. Why cartilaginous fishes? Because I don't know why they didn't call them, because we have two groups of jaw fishes, one that are bony and ones that have cartilage. But let's begin with our cartilaginous. Cartilaginous. Difficult word. Spelling bee word. Cartilaginous fishes. This group is, now they have a jaw. And actually they are very much recognized because of the jaw that they have. This group is the ones that include the sharks. Yeah, do they have a jaw? Yes, sir, they do have a jaw. Actually, their movies are called Jaws, right? Durón, in English, is called Jaws, the movie. So, cartilaginous fishes don't only include sharks, but they also include rays, like the manta ray. Have you seen this fish? Like, well, yeah, we have an example here in the book. The manta ray, the rays, and other types of sharks, different types of sharks. Maybe you've heard of the hammerhead shark, the cabeza de martillo. We also have a shark that has a saw, the saw-faced shark, el tiburón sierra. Yeah, I'm gonna give you some photographs on the class. I'm gonna send you a presentation of some different examples, the most notable examples of the different groups. We also have the different types of sharks. All the sharks belong to them. We have the whale shark that we have in Honduras. We have different types of sharks like the white shark, the reef shark, the lemon shark. Sharks. Who doesn't love sharks? Everybody likes sharks. Now, but because we're talking about evolution, and evolution did not end here, obviously, another group evolved from the cartilaginous fishes. And this group is bony fish. Now, cartilage evolved. This is one of the structures. Cartilage evolved and it became harder. And that is why fish, when you eat tilapia or any fish that you eat, they have spines, right? And these spines are not cartilage. They are spiny, they can kill you. You could get strangled in them. I don't know. They are bone. and we have seen the bone also. Actually, cartilaginous fishes have a little part that is bone. Their vertebrae, the vertebrae is bony, and also the jaw. The jaws of cartilaginous fishes are bony, but not their skeleton. So the skeleton of a cartilaginous fish is of cartilage. That's why if you ever eat shark, have you eaten shark before? I have. It's really good. When you eat shark, you don't have to worry about the spines because the spines are made of cartilage and you just eat them. They just pass through you. Now, so bony fish are the ones that we are most familiar with. Well, sharks, obviously, we are familiar with. Manta rays, we are familiar with. Bony fishes, we are most familiar with. Which? Because they are the most evolved fishes. They are the most abundant. You see that every little bit of evolution gives you an advantage, Which is the most diverse group of fishes? Bony fishes. Which is the least diverse? Today, jawless fishes. These guys are primitive organisms. They are barely surviving, they are very good at surviving, but as a group, they only have 2 members today. Imagine that, only 2 members. While cartilaginous fish, we have hundreds of different sharks. We have dozens of different rays. But bony fishes, we're talking about thousands of different species. We have tilapia, guapote, salmon, atún, you name it, clownfish, frogfish, parrotfish, even the caballitos de mar, are they called? I don't remember the name right now. But those are, hippocampus. They are fish. We have different types of fishes. Enormous types of fishes. The eels, the anguilas, fish. You name it. You name it. We have so many different types of bony fishes. Here we have, this is one eel, for example, laying its eggs. So in diversity, when it comes to diversity in the ocean, invertebrates, because all of this group that I'm going to put here in green, from here on, we have vertebrates, people. We have vertebrates. From here on. So from the green side up, we're going to have our vertebrates in our evolutionary tree. Fishes are the first form of vertebrates because they form a vertebra, which is the vertebra that all of the vertebrates have. That is one thing that we have in common with all our vertebrates, and that is one of the other evidences of evolution. Now, to finish, I want to finish with, actually I'm going to finish with this because time is up. We have concluded our 45 minutes of class. And all of this is a lot of information also. So what we're going to do, we're going to leave it here. And this will be the subject of your first quiz. Your first quiz is going to be Monday. So this Monday, I will give you a quiz that will be on the platform, on the internet site. And you just have to, search it and hook up the link, like you did for the class. So you have all day to do it. Please do not use Google. Just, you can use the book. You can use, but don't copy paste the questions to Google. The idea here is to learn, to learn something. Try to study. Try to do this for the own passion of being a human being, which is learning. I promise you that just as I have learned this, you can also learn all of this cool information about science, about social studies, about the world, if you dedicate yourself to studying. So I invite you So for the next class, we're gonna see how bony fish, all the different types of bony fish, how you know they became, they led, they led the way to for us and for all the other vertebrates. So thanks for having you here. I hope you enjoyed the class. It was nice imagining that that you're paying attention to me. I really like giving you classes. So, and I hope you enjoyed it as well. And see you next time, kids. This is going to be our schedule for the science class. It's going to be Friday at 1 p.m. You know that the link is going to be also on the platform. So have a nice weekend, class, and remember that we have the quiz Monday. Nice to see you, everybody. Leave your comments over here if you have any questions or anything else that I can help you. You can also use the chat. See you later.